Guys, welcome back to another leak code video. As you can see, my streak's back at 1. I was at 40. I was at a hackathon and I forgot to do it, and there's literally like a 1 more left until I get the monthly badge for January. But yeah, I missed it. So you can hear how deep my voice is, because I've just been yelling because of this. But yeah, enough of that. Let's get back to the video. Today we're going to be solving the leak code daily, February 1st. 120. No, I think it would be like February 2nd in like Chinese time, because pretty sure that's what it's based off. So 1900 1291 sequential digits. So this is a medium problem. An integer has sequential digits if and only if each digit in the number is one more than the previous digit. Return a sorted list of all integers in the range low to high, inclusive, that have sequential digits. Example 1. Okay, so for this, uh, between these two is only these sequential digits. And then for this one, it's all of these. Has to be sorted, and here's the time constraints. So it can't be like, because technically 1 is sorted, 2 is sorted, 3 is sorted, all the way to like 9. So yeah, basically it can't be those. Well, I mean, right off the bat, I'm pretty sure everyone had the idea of just generating all sequential digits. Nah. I mean, it's technically O of 1, right? If you if you generate all digits, even digits. Actually, never mind. I'm gonna stop right there before I get myself into some trouble. Okay, so what we're gonna do is we're just gonna start off with a final. That's what I like to call my return arrays, because that's what we have to return. So one thing you would notice is that the only important digit in this whole array of numbers is just the first digit, right? Because the constraint is that whatever the first digit is, the next has to be one, uh, that digit plus one, and then so on. So this digit really determines everything. Uh, Also the problem asks for it to be sorted, right? So for it to be sorted, I mean, fastest like sorting algorithm just do n log n, right? But we don't want that. So actually a really intuitive way to do this is using a queue. So in LeetCode you don't actually have to import it, but regularly you'd have to import DQ from collections. Basically it's a doubly linked list, right? So you can go backwards and forwards. And what's good about it is that to pop from the left or the right is O of 1. So I mean that's much better. So let's go ahead and just initialize that. We'll call it just call it Q. Uh, and then that's how you would call initialize it, right? So this Q of ours, as we talked before, only this digit matters, right? So and there's only so many digits that this digit can be, right? I mean 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we can just add that here. Uh, I'll try hard coding it after, but for now we'll just do the range. So now we have this, right? So something really cool is that, let's say how do I, okay, yeah, so right now this would be 1, 2, 3, 4. 5, 6, right? So uh what we could do is, so we would get 1, right? We check if it's in the range. It's not. So then we get 1 times 10. So that's just 10. But that's not the correct number, right? It should be 1, 2. So what we do is we we go down and we do, I mean, before we time, I mean, yeah, we could just, yeah, actually here we would just do modulo 10, right? So 1 can't go into 10, right? So just return 1, right? And then, so it's just this 1 plus 1. So we would just plus 1 to it, and then we would get 12. And then we would just add that. And then basically we would just keep on going. And we would only check if it's in within the lower bound, I guess, because if it's not, then we just stop, because no matter what you add to it, it's still going to be higher, right? Yeah, so let's start. So what we're going to do is you're going to while the queue exists, has stuff in it, uh we're just going to pop left like I said. So we would get that 1 at the beginning, so we just call left equals q dot pop left. And then, as I said, we only check if it's in the lower bound, right? So if it's not, this is like a early return. So if it's greater than high, then we just forget about it. So a cool thing Python has, I'm pretty sure a lot of languages has, is this continue, right? So we'll just go into the next iteration. It wouldn't even do the rest of the calculations. So I mean, that saves some computing power, and yeah, some runtime. So now we have to check if the number we have currently is within the range, right? So if I mean, we could like just do like if left less than, I mean, greater than or equal to low end uh left less than or equal to high. Like, this is one way to do it, but it's actually I don't know, it looks nicer to me. We just do this, right? So that's literally just this. Yeah. So if it's in the range, right, we would just add it to our final, right? So just do final dot append uh left. Now remember that part I was talking about, the division and modulo. So we'll just call it before. So like the number before is equal to left. Oh, right. So that's just gonna give us a like a 1, 2, 3, 4, whatever, like 1 to 9. And then one other thing is that um it can't be a 9, because if it's a 9, then it would, if we add 1 to it, then it would be a 10, right? And we can't do it with a 10. So we see if before mm, hmm sorry, I was just thinking another way, but like if it's less than 9, then we would do we would do q dot append. I'm pretty sure this is the method. I haven't really used it much. So we just add like left times 10, right? So that would give us, like, if it's a 1, it would give us 10, right? And then we would do plus uh left, I mean not left, before plus 1. Okay, this should be good. Just some cool facts, I guess. Um, the number of combinations it can be is 81. So this is the max number of arrays that they can be, because there's only 81 different sequential digits between uh 1 to uh, yeah, 1 to 10. I mean to 9. Like, but in this. Okay, let's run this. Okay, let's submit. Okay, so let's try this hard coded. I'm not sure if it's like this. Oh, this might not work, but I might have to send it. Oh, okay, yep. So it's not this. So it's, is it an array? Maybe it's kind of the same amount of computation. Oh, never mind. Yeah, so yeah, nice trick over there. And now it's pretty fast. Thank you guys for watching. Look out for a video tomorrow if it's not a dynamic programming hard. And yeah, I'll see you guys tomorrow.